All right, let's talk about AI security. In the world of AI, security isn't just some optional feature, it's the whole fortress. But, how do you actually build one? Today, we're going to break down the three essential frameworks that come together to form a truly unified, resilient defense for any AI system. So, this is the big question every single organization using AI really needs to be asking itself. Because let's be real, deploying an AI model without a solid security strategy, that's like leaving the keys in the ignition of a brand new sports car. It's not a question of if something will go wrong, but when. And this is a whole new ballgame. Your traditional cybersecurity playbook, it's just not enough here. AI brings this massively expanded attack surface with all these new vulnerabilities in how models are trained and how data gets processed. Attackers are getting creative, using brand new methods like prompt injection, where they can basically trick the AI with malicious instructions, or data poisoning, where they corrupt the very data the AI learns from. These are threats designed specifically for AI. And, to top it all off, the regulatory pressure is ramping up, demanding real governance and risk management. To build our fortress, we've got to start on the front lines, with the developers. And their first line of defense is what I like to call the developer's shield, the OWASP framework. So, the Open Web Application Security Project, or OWASP, put together this top 10 list specifically for large language models. You can think of it like a developer's field guide. It points out the absolute most critical security risks they need to be thinking about while they're building an application. The whole idea is to build secure code from the inside out. So what's at the very top of that list? The number one most critical threat identified by the folks who know this stuff best? Prompt injection. And it is number one for a very, very good reason. A carefully crafted malicious input can completely hijack an LLM's intended behavior. And the scary part is, these attacks are often shockingly simple to pull off, but they can have absolutely devastating consequences, from leaking sensitive data to making the AI do things it was never meant to do. Now, what's so great about OWASP is that it doesn't just point out problems, it gives you solutions. For that big one, prompt injection, it recommends things like strict input validation. To stop unlimited consumption, where someone abuses an API, it suggests rate limiting and cost monitoring. For every single vulnerability, there's a clear, actionable mitigation strategy that the development team can build right into their code. Okay, so we've armed our developers. But a strong defense means you have to understand the offense. To do that, we need to look at the battlefield through the enemy's eyes. And this brings us to what I call the attacker's map, the MITRE ATLAS framework. So if OWASP is all about building the walls, MITRE ATLAS is about thinking like the person who's trying to climb them. It's an adversarial threat matrix. It's actually modeled after the legendary ATT&K framework from traditional cybersecurity, and it meticulously documents all the real-world tactics and techniques attackers are using against AI systems. It really lets you see the battlefield from your opponent's perspective. So how does an attacker think? Well, Atlas breaks it down into this clear path. It starts with reconnaissance, just gathering public info. Then, for initial access, they might use that very same LLM-01 vulnerability we just talked about, prompt injection. From there, it's on to execution, running malicious code, and finally, impact, where they try to disrupt your entire system. Atlas literally maps out every potential step an adversary might take. So we've got the developer's shield and we have the attacker's map. But who sets the rules of engagement for the whole kingdom? That brings us to our third and final framework, the Governor's Rulebook from NIST. The National Institute of Standards and Technology created the AI Risk Management Framework, or the RMF. Now, this is a high-level, voluntary guide. It's not about code, it's not about attack tactics. Instead, it's all about governance. It gives organizations a structure to manage AI risks and to promote trustworthy AI, from the boardroom all the way down across the entire system lifecycle. But what does trustworthy actually mean in this context? Well, NIST defines it with these 6 essential pillars. A trustworthy AI system has to be robust, reliable, fair, and explainable. It has to protect privacy, and of course, it must be secure. These are the principles that should be guiding every single decision. And to put those principles into practice, NIST gives us 4 core functions that work in a continuous cycle. First, you govern by setting policies. Then you map your AI assets and all the risks. Next, you measure your exposure and test the system. And finally, you manage those risks by putting in controls and responding to incidents. This isn't a one-time checklist. It's an ongoing process of improvement. Okay, So we've looked at the shield, the map, and the rulebook. Now for the most important part, putting them all together to build that unified defense. This might be the most crucial point to get. These frameworks aren't competing with each other. They're complementary. They're teammates. You have OWASP, that's the developer, securing the code from the inside. You have MITRE ATLAS, that's the attacker, looking for weaknesses from the outside. And then you have NIST, who's like the governor, ensuring trust and accountability from above. A complete defense needs all three perspectives. Let's make this really practical. During development, your team is using the OWASP guidelines to build a secure foundation. Then, during testing, your security team uses MITRE ATLAS to run adversarial tests and really think like an attacker. And throughout that entire lifecycle, you govern with the NIST AIRMF to maintain risk oversight. Develop, test, govern. It's a fully integrated lifecycle. By weaving these frameworks together, you're moving way beyond just simple one-off fixes. You're creating a multi-layered defense. And that is how you build deep organizational resilience that protects your AI systems from the code level all the way up to the strategic level.
So, how do you organize all of this? Well, we can actually boil it all down to a simple but really powerful 4-layer model for putting this whole unified defense into action.
Here's the complete picture. It starts right at the foundation with the application security layer, and that's where your developers are using OWASP. Right above that is the threat intelligence layer, where you use MITRE ATLAS to understand your adversaries. The next 2 layers are guided by NIST. You've got risk management and, at the very top, governance. Each layer builds on and supports the others. It's a complete system. So this leaves us with one final question to think about. Now that you've seen how these frameworks all fit together, take a good look at your own strategy. Is your AI security just a single lock on the door? Or are you building a true multi-layered fortress?